Okay. This is going to be a short review. The main thing I want to focus on in this video is uh, amines and amide reactions. Uh, those are the ones that typically give students trouble. So I want to go over that section again. All right. Okay. The thing about amines is they have this nitrogen with an unbonded pair of electrons there that tends to attract cations that need electrons to form a full shell. And that's what goes on here. So that hydrogen ion that's present with an acid then grips that unbonded pair on the nitrogen and forms a covalent bond, and it's called a coordinate covalent bond. Additionally, that forms an ion salt. Now, excuse me. Okay, this is real important. You will see that next Monday. Okay. If you have a weak acid in an acidic environment, nothing will change, no reaction. If you have a base, what will happen is you'll form the ammonium salt because of this here. In an alkaline condition or a basic condition where pH is greater than 7, the weak acid then forms the salt. And there's no reaction with the base. Okay? And that's one way you can diagnostically identify acids and bases by changing the pH environment and see how the ionic conditions change. Okay, in terms of naming it, okay, when this hydrogen goes over to that nitrogen, we end up forming an ammonium ion along with whatever that salt is. So in this case, it's methylammonium chloride. So methyl ammonium chloride. Another example would be if we have this amine here, ethylamine, in an acidic environment where that H goes over to the nitrogen, forms the ammonium cation plus the acetate anion. So this whole thing is considered a salt. Another example would be in terms of naming. Okay, so we've got, let's erase this stuff for a second here. Excuse me. Okay, so we have a ammonium cation formed here. The anion, associated anion is bromide. And then the amine part is going to be ethyl dimethyl ammonium bromide. Similarly, we're going to have a we're going to have 3 ethyls, so that's triethyl ammonium acetate. Okay, because the polarity of an ionic compound is much more soluble in water, frequently drug manufacturers will tend to make any group that can become polarized, like forming an ion. They will do that to make it more water soluble. And this example here is morphine. Now morphine's got some hydroxyl groups here, which makes it soluble in water. However, without the acidic environment here, this tends to be very nonpolar and dominates over the hydroxyl groups. Well, once we form this ionic compound up here, we've got polar hydroxyl groups, a ion, super soluble in water. So this non-polar part here is overwhelmed by the combination of the hydroxyl groups and the ammonia cation. Okay, if we introduce a hydroxyl ion, that can grab hold of that hydrogen there and pull it off, forming water. Okay, so we saw in the past, when we're looking at forming esters, okay, to form an ester, there are three ways to make an ester. There's the acid plus alcohol, acid plus anhydride, and acid chloride plus alcohol. And the yield is most with the acid chloride, the least with the alcohol and acid. Forming an amide, which is similar to forming an ester, we've got three ways to make it. However, the acid and amine by itself is horrendously low yield to the point where it's considered no reaction. So the only way to make an amide is with an, this is not, let's see, the acid anhydride plus the amine will give you an amide, or the acid chloride plus the amine will give you an amide. Okay, so the acid plus amine basically forms a ammonium salt. And like with esters, the side of the amide bond that has the carbonyl group is the acid part, and the part that has the nitrogen is the amine part. And this comes in handy when you're trying to synthesize something or when you're trying to name it. And one way to qualitatively distinguish between tertiary amines and primary and secondary amines, tertiary amines do not form amides, or primary and secondary ones do. So we always have to have some kind of an acid. In this case, it's the anhydride. And the amine, in this case, it's just plain old NH3 ammonia. And when those two react, we end up by kicking off. Remember, an anhydride is like a dual ester. So what happens is one half of the anhydride is kicked off as the acid, In this case, it's a 2-carbon acid, which is acetic acid, common name, or ethanoic acid, which is the IUPAC name. And then this would be the name of the amide. Here we have an acid. This is inclined. The acid chloride plus the amine gives us the amide. In this case, because there is a methyl group off that nitrogen, we have to specify with an uppercase italicized N. So this M-methyl corresponds to that. And then this benzamide is from benzoic acid, and it's an amide. And because it's formed from the acid chloride, we end up generating hydrochloric acid as well. Here we've got benzyl chloride again, this is based on benzoic acid. We have the amine, in this case, it's dimethylamine. And then when we form the amide, we have 2 methyl groups coming off of the nitrogen. So that's going to be NN dimethyl benzamide. Okay, so in general, when we put an amine in water, it's going to form the ammonium ion. If it's in an acidic environment, it'll form the ammonium ion as well, plus the salt. If we have an acid chloride or acid anhydride, we can form the amide from the amine plus the either acid chloride or acid anhydride. So the ic acid is replaced by the amide. So formic acid forms amide. Ic acid, amide. And then the N, uppercase, italicized N, is used to denote anything coming off of that nitrogen in terms of either an amine or an amide. So in this case, we had 1. You can say monomethyl if you want. It's optional. Most people don't put it there. And this methyl group is coming off the nitrogen. Here we have 2 methyl groups coming off of it. So you have to say NN. It would be like saying 1,1 or 2,2 or something like that. Dimethyl acetoamide. Okay, so with the nitrogen, there is some hydrogen bonding. Not as much as with oxygen, because it only has 1 unbonded pair, where oxygen has 2 unbonded pairs. So it does do hydrogen bonding, hence its boiling point, melting point, surface tension is greater, but not as high as the acids. So the acids are going to have highest boiling point, melting point, and surface tension. The alkanes are going to have the lowest. Now we can hydrolyze amide bonds by the introduction of water plus acidic or alkaline or base environment and with some heat. And this is what happens with proteases in your stomach. It undergoes hydrolysis, and it's very common. So now this hydrolysis reaction is important because it depends on pH. pH will determine the product. If it's an acidic environment, you're going to end up with the acid plus the amine salts, which is the ammonium salt. In an alkaline environment, we're going to end up with the salt of the acid and the plain amine. So know that. Okay, so we have an acidic environment being hydrolyzed with water. So that means what's going to happen is we're going to end up with that H going over there, giving us the ammonium chloride and the acid. Same with this. We end up with the ammonium chloride and the acid. And again, in this environment here, we've got, it's an alkaline or basic environment. So what happens now is that the acid that would form normally, the hydroxyl ion will take that hydrogen, form water. And you'll end up with the salt of that acid. And you'll end up with an non-ionic amine. In nature, there's a ton of amides all over the place. All over the place. Okay, so that's what I wanted to talk about regarding amine reactions. Okay, that's the main thing. Now, your test is going to be in room 107 downstairs at 12:45 for 2 hours. Okay. Now, if you have not turned in your project today, you may turn it in on Monday. Also, if you aren't going to be coming in, I need to see your notebooks and show me those on Monday as well. Okay.